Hello everyone, welcome to the 10th video of our Grind 75 series. And today's video is about finding the lowest common ancestor of a binary search tree. So in the question will be given a binary search tree and two other nodes which are P and Q. We must find the lowest common ancestor. So what is the lowest common ancestor? Lowest common ancestor is when we are between two nodes, which is the most common, which is the parent node, which we'll be finding. That is what we'll be finding. We'll be finding the nearest parent of the two nodes. And we are also node can be a descendant of itself. So a node can be the descendant of itself. That is also a condition. So how do we solve this? We can solve this easily using recursion again, obviously. So what are the conditions that we must give? So let's go over here. In that, assume we have a binary search tree, which is 20. And we know one thing that in a binary search tree, the left nodes are always lesser than the root, and the right nodes are always greater than the root. So if our P and Q both are greater than the root, which means our lowest common ancestor or the parent will lie in the right sub. Both are lesser, which means the parent lies in the left sub. So this is one thing that we know. So let's implement the thing. If both P and Q are less than our root, will search in the left subtree. If both are greater than the root, we'll search in the right subtree. And if one one is less and the other is greater than the root, which means the root is the lowest common ancestor. So here we have P as 5 and Q as 15. Both 5 and 15 are lesser than the root. So we search in the left sub. Now we come to 10. 10 is our root. We see that both P and Q are lesser than the, sorry, 5 is less than 10, but 15 is greater than 10. So our root is the answer. So 10 will be our answer. So what if we take 5 and 35? So yeah, 5 is less than 20, whereas 35 is greater than 20. So the root is our lowest common ancestor, which is the very simple approach. And as we are using recursion, we need a base case, obviously. So if our root is a null pointer, we'll be returning a null pointer. So our first condition, if our root's value is less than p's value and if our root's value is less than q's value, which means we must return the left subtree. So both p and q are greater than the root. So we must go to the right subtree, sorry, right subtree and p and q. So the same condition will be just will be like greater than if both if our root value is greater than both p and q, which means our element lies in the left subset. So yeah, if both the conditions are not met, we'll be returning the root. This should run. Actually, yeah, let's check the yes, this has run. Time complexity is O of log n as we'll be dividing as we'll be eliminating the other half of the subtrees all the time. So this runs in O of log n complexity. Thank you.